Hi, everyone. Welcome to the Industrial Problem Seminar. It's a great pleasure to introduce Dr. Mitch Kinney from MITRE, and he's going to talk about working as an artificial intelligence advisor to the US government.
All right. Well, yeah, thank you guys so much for having me and for giving me a chance to talk to you guys. So today, what I'm going to talk about is kind of what my company does as advisors to the US government, and also kind of my role as somebody that works at the company, and then going to give you just an overview of an example project or a problem that I worked on during my first year at the company. So just to kind of give you guys a bit of my background. So I did my undergraduate at the University of Iowa, where I got a Bachelor's of Science in Math, Computer Science, and Statistics. And then I came to the University of Minnesota as a PhD student in statistics. And while I was a student, I did a couple of internships at the NASA Jet Propulsion Laboratory in 2018 and 2019. There I worked mainly with the robotics department on kind of an object detection problem using different cameras on boats. The idea was to try to be able to track an object through video. And so just not having any ground truth, just being able to decipher exactly kind of where boats were in these images over time. And then after I got my PhD, so I got my PhD in a natural image processing problem. My focus was trying to figure out how to condense down information from a very large amount of information from maybe a textbook or something, and use that information to do some sort of question answering. And this was based on a problem that was posed to me at the JPL Jet Propulsion Laboratory, where they needed to solve a problem that as rovers kind of went out into space further and further away and communication got more and more difficult coming back to Earth, how could they really embed a lot of that information onto the rover that they could autonomously decide what to do and what to explore on these kind of extraterrestrial surfaces. And so one way that they kind of proposed was being able to give it all of this written information about sort of lab tests and what the scientists were looking for, and for it to be able to deduce based on what it saw on these extraterrestrial surfaces, the best way to kind of navigate or to do science experiments without interaction of humans that would be very expensive. So that was kind of the inspiration for the dissertation. Today, though, I work as an artificial intelligence researcher at the MITRE Corporation. So a little bit of information about MITRE. MITRE is a manager of federally funded research and development centers. So there's 6 federally funded and research and development centers that MITRE is kind of the big umbrella for. And what that means is that MITRE itself is not a part of the US government, but we are entirely funded by the US government. So MITRE is what's called a not-for-profit, which means that we're not out to make a profit. We're not out to increase any sort of shareholder value in stocks or anything like that. We're just being funded entirely by the US government to solve various problems that are of interest to the US government and act as kind of like a pool of experts that the US government can rely on when they don't have kind of that in-house expertise. So as you can see, MITRE is quite a large company. It has locations nationally and internationally. So the main hubs of the company are in the DC area and the Boston area, but we also have representation in Hawaii, Colorado, Japan, Germany, Texas now. So it's a very, very large company with a large amount of projects going on at one time. And just to give you kind of an example of a classic MITRE kind of problem is one where if a government agency has a need for some sort of technology, maybe like a cybersecurity solution, that they don't really have the expertise in-house for understanding what's available, what needs to be done in order to solve this cybersecurity problem. What they can do is outsource this kind of problem to MITRE, and MITRE is going to go through the legwork of evaluating what's kind of out there in the market today to solve this problem, what's going to be the best solution for this problem, and then deliver that information to this government agency to say, okay, we've evaluated a bunch of these vendors. our kind of non our kind of opinion about what would be the best solution is going to be this if you want to actually buy this solution in order to solve your problem. So MITRE kind of really serves as that conduit between the government and private industry, where our best interests are in the government's from the government's point of view, because that's where kind of all of our money comes from. So the 6 FFRDCs that MITRE actually runs are the Center for Advanced Aviation System Development. This is a lot of like the FAA, so a lot of kind of for the airplanes and different modes of transportation, enterprise modernization, health FFRDC, Homeland Security Systems. So this is Department of Homeland Security. National Cybersecurity, I believe, is US Cybercom, and the National Security Engineering Center, which is a lot of the kind of military and intelligence communities. So if you want to think of kind of an FFRDC, some other more typical examples, so NASA's Jet Propulsion Laboratory is also FFRDC that's managed by Caltech. So it's kind of another example, kind of a more famous example of an FFRDC. But yeah, so kind of what MITRE's role is as the manager of all these FFRDCs is to be able to work with these different government agencies in this specific area and provide this kind of expertise. So how MITRE is split up is 5 of the FFRDCs are what's under the public, what's known as the public sector. The national security FFRDC is under the national security. And then there's another area where I work, which is called the MITRE Labs. So what MITRE Labs is a collection of people who don't work for any specific FFRDC, but has some sort of expertise in an area such as artificial intelligence, modeling, simulation, biology, cybersecurity, program management, just different areas like that, that we can kind of get loaned out to these different FFRDCs that their sponsor may have come up and said, oh, we need help solving this problem. Can you use MITRE as a resource and see what kind of people are available to actually help us solve this problem? And so, yeah, go ahead, Christian.
I'm just wondering how many people do you have at this particular section labs, and maybe what proportion of you have?
Okay, so I don't know actually how it's split out, so I don't think I can answer that. I think as far as PhDs, there's approximately, I would say, especially in MITRE Labs, there's a lot more kind of PhDs. So my like rough estimate would be like 20% or so of like people in MITRE Labs has a PhD. A lot of the people that work in kind of the public sector or national security kind of come from those parts of the government already and kind of brought their experience and expertise from working in the government to those kind of areas. And so there's a couple here and there, but not quite as many. The people in MITRE Labs are the ones that have kind of the expertise in more of the deep dive kind of fields that the government may be interested in. So they're a lot more kind of R&D and research focused. So in MITRE Labs, we're not really beholden to any like sponsor or federally funded research and development center. It's really kind of where we're needed is where we go. So some things, these are kind of the big, probably successes at MITRE over the last kind of few years. And so kind of to demonstrate what it is that MITRE is really striving for and capable of. So this ASIAS program, which is the Aviation Safety Information Analysis and Sharing Program. So this is a partnership that comes from the FAA, where all the different airlines, so United, Delta, Southwest, all share their kind of safety information with MITRE, and then MITRE is able to kind of aggregate, anonymize it, and then share it back with these airlines in order for them to be able to kind of build on it to make their own flights safer and make their own kind of travel much better. So this is kind of something where individual airlines may not see a benefit with really sharing their proprietary data, but overall, if they're able to access other people's data as well, then they might be able to derive some benefit from it. And it wasn't something that a government agency itself could really host the data and be able to do all the kind of a sensitive analysis of it. And so it kind of got outsourced to MITRE as somebody that could apolitically and without any sort of beholden to a certain company's objective or anything, kind of house that data and be able to share it with among all these other airlines together. Another thing is the attack. So this stands for the MITRE Adversarial Tactics, Techniques, and Common Knowledge. This is a kind of common language that people can talk about different cybersecurity intrusion events. So if somebody is kind of trying to hack into your system, before kind of attack, it was very varied and people's vocabulary were kind of all over the place, and you couldn't really share this information succinctly and quickly. Where what MITRE attack did is it kind of enumerates all the different ways that a hacker can get into the system, what they can do within the system, what they're able to kind of attack, delete, exfiltrate, things like that. And so now when somebody's system is getting infected, they can use this MITRE attack to kind of say, okay, they're using this technique to actually get into the system. Once they were in the system, they use this technique to evade detection, and the damage caused to our system was this. And so it kind of gives a very easy to follow roadmap of how an attack took place, so that any sort of diagnostics can cover that, or if somebody else is also possibly a target of this hacker, they can understand what they need to look out for, when this attack might possibly occur. So, and so this is kind of a way that you can communicate very easily in kind of a common language that everybody understands exactly what is happening in this computer hacking event. These last two, I'm not quite as familiar with them, but I believe it's kind of a pretty common theme of MITRE, where we're trying to connect private industry and government and utilize the resources of both in order to kind of create one big partnership collaborative solution that is going to be helpful kind of to everybody, not a specific company, not just for the government, but kind of be able to work between those areas and create something that is good for everybody, kind of the benefit of the whole. So diving down a little bit more specifically into artificial intelligence division specifically, where I'm at. So this is kind of some corporate speak about what it is kind of we want to do. So you can kind of see about how we want to really work with the government and these private industry and academia kind of roles in order to build these collaborative solutions, even for artificial intelligence kind of specifically. So as an example, so we might work with NIST, which is the National Institutes for Standards and Technology, about what sort of regulation AI should have. So what is it that these companies like Microsoft, these Googles, what are they doing with AI? What is it that maybe the government should be wary of? What is it that we think is going to be a safe kind of way to use AI, and make those recommendations to NIST in order to kind of promote a good, fair usage of AI. And then going the other way, maybe something like DARPA here, which is, I believe, the Defense Advanced Research Projects. I'm not sure, but DARPA might say, okay, what is the latest and greatest technology coming from Microsoft, from Google? And we can go the other way as well and try to provide the government those solutions that we evaluated as kind of the best state-of-the-art methods. A little bit more focus areas in my division. So one of them is AI assurance. So this is kind of like I was talking about, where artificial intelligence has really been geared more just towards performance. So it's like, how well can an artificial intelligence agents do? A lot of talk in the beginning wasn't really focused on, okay, but when we start replacing humans with artificial intelligence, what are we losing? What are those human aspects that we're losing? And what assurance is trying to do is say, okay, these AI agents have to be safe, they have to be reliable, they have to be robust, they have to be fair, they have to be unbiased. How do we build those kind of qualities into this artificial intelligence that we may be losing with humans And more importantly, how can we make sure that they're actually integrated into these systems? We can't maybe just rely on a company that's going to be saying, oh yeah, we did all these things here, buy our product. We need to actually have sort of tools that we can use to assess these artificial intelligence solutions for these different areas that normally we can trust a human to do, or at least have consequences for the human if they aren't done. Another area is this courses of action exploration. So this has a lot to do with decision-making artificial intelligence. So once decision-making is kind of being advised now by artificial intelligence agents, and the problem space is just so huge, the decision space is exponential. Like when you're talking about kind of a military operation of trying to decide where you want to send troops, what you want to do with those troops, there's so many different decisions about where they need to go, specifically how many need to go, that once you make one decision, then the next step is going to just also present you with a bunch of different options. And so being able to sort of effectively make those decisions in a timely manner and give recommendations that are going to be useful to these decision makers is one area that we're focusing in as well. Then the last one is this idea that MITRE is the kind of in-between for private and public sector. And so how can we utilize this private sector data that can be used for the government? And then also, how do we make sure that it's not being used nefariously? So being able to kind of understand what data is needed by these different government agencies, how this data can be used is something that the government relies kind of on us on to evaluate and bring these kind of solutions as far as what is going to be most cost effective. Some big kind of projects that have come out of the artificial intelligence and autonomy division specifically has been this ATLAS. So this ATLAS stands for the Artificial Intelligence Threat Landscape. And so what ATLAS does is kind of similar to what ATT&CK has done, where instead of talking about a cybersecurity threat incident, we're going to start talking about how can people adversarially attack artificial intelligence. And so this is kind of what you can do to kind of enumerate all the different ways you can either attack an artificial intelligence agent, and then what you can actually do once you've infiltrated it successfully. And so the different headings here are different things you can do. So you can perform reconnaissance on an artificial intelligence agent, either by looking through Google searching, what does this government agency use for its artificial intelligence, or if it has an API, maybe calling the API a lot of times to understand what sort of output it's getting from the artificial intelligence agent. And then once you do this reconnaissance, maybe the next step would be that resource development and so on and so forth. So this is just kind of, again, doing what ATT&CK was doing, where it's giving a common language for people to understand what is possible to do when attacking an artificial intelligence agent, and then what can be done once that artificial intelligence agent is sort of attacked. And then on top of this, so one thing that we did on top of ATLAS is be able to actually do an autonomous red teaming of an artificial intelligence agent. And so if you have a system that has an artificial intelligence agent on it, then what I believe this is called, what is it called? I have it here, but it's covered by the Zoom. Arsenal. So what Arsenal is trying to do is it's trying to team up with another MITRE product called Caldera to actually infiltrate a computer system and then attack an artificial intelligence agent, where it might be sitting at rest in some folders. The data might be open. And so what it's going to do is it's going to look for that data. It might poison that data in some way. It might extract the model weights of the artificial intelligence agent. It might change the model weights, different things like that, all done kind of autonomously in order to help companies see what is kind of in the realm of possible for when an adversary is trying to attack your system. All right, so that was kind of an overview of the company, what the company does, and then what more specifically my division does. Now for kind of what I do specifically day to day. So I am a senior artificial intelligence researcher. At the company, I think there's like 7 levels. And so associate, intermediate, senior, lead, principal, senior principal, and distinguished are kind of the levels that you can get at. And as you kind of transcend the levels, as you go up higher and higher, the trade-off for work, for what you do as far as like development work, kind of gets less and less and more towards the managerial work, whether that means actually like managing people or managing projects. There's a few different paths you can take within MITRE. And so what that means is that you're going to be writing a lot more emails, you're going to be writing a lot more proposals as far as like what can MITRE do for the government and how can we help the government. And then kind of unique at MITRE is that there's also a technical path where you can just be very involved in kind of the research, either by contributing to textbooks or contributing to being like an adjunct professor kind of thing at different universities. And so the easiest way probably to rise up in the company is through that managerial of people, but there's also kind of a technical role that if you're highly regarded in your field inside and outside of MITRE, it's another way to progress. So I joined MITRE in 2020, so kind of at the very start of the pandemic. And so a lot of the at-home, kind of work-at-home infrastructure was built up. But the 3 different kind of places that I work are mainly at home. Sometimes I have to commute into the office, and sometimes I have to be actually going to a sponsor site to work on their data that is there and nowhere else. And so luckily there's not a lot of times when I have to do that. So working at home mainly. And then some of the questions that I can help answer when a government sponsor comes to us is, can AI help us do this? So they might say, here's our problem. Is this something that AI can solve? So we have a problem where we want to do maybe sort this information a bit better, a bit faster. Can AI help us do this? Or does this technology exist? Maybe they say, oh, I saw this really cool thing. I read about this in a magazine or in a paper. Is this actually feasible, or can it be created? So we can serve as advisors to that. One of the roles I'm in right now really hints at this next one, this open questions. So one of the roles I'm in is trying to help a sponsor further kind of the field of research in AI assurance. So this was that, can AI be safe? Can AI be reliable? Can AI be robust? And so what they want to do is kind of fund some efforts in this area to actually have people do research that they might be able to use or they might be able to not use, but just further this field of research. And so the questions that they came to us about were, well, what should we fund? What should we fund? What is it out there that would be interesting, that would be useful to the field of AI assurance? And so a large part of it was doing research about what are the latest and greatest methods in AI assurance, what are kind of the open questions of AI assurance, and then what is kind of feasible to fund within like a 2-year study. Like we don't want to hit the home runs, we don't want to hit the grand slams, you know, we have enough money for like kind of like a 2-year study, what is feasible within that time frame. So that's something that I'm personally helping out with right now. And then kind of one thing that I'm going to be talking about today is about prototyping. So a lot of times either MITRE will come with an idea or a sponsor will come with an idea and say, okay, we might want to fund this, but we don't know how feasible it is. Can you prototype it for us? And then if it actually is feasible, go out and find somebody to build it for us so we can buy it. So I'll be talking about something like that, a project that I was on in my first year. And then also, how can we make this better? So maybe they have a solution, the government sponsor has a solution, they bought a product, but maybe it's a little bit outdated. So they come to us and saying like, all right, well, the person we bought it from isn't going to be updating it anymore, isn't saying that it can be any better, but what do you think? What do you guys think? Can it be better? Can you do better? What is your kind of thoughts on this? And so, yeah, so those are kind of the questions that I've answered to kind of help with through my different kind of projects. And then, oh yeah, go ahead, Christian.
Do people in your team get to write papers?
Yeah, I've written some papers. So yeah, so this project that I'm going to be talking about is a paper of like kind of a research prototype thing that was written. I think my department's a bit unique in that, where the paper writing is kind of held up as kind of something that would be really good to do, kind of just to get the name out at MITRE. I think MITRE as a whole probably falls more towards the government side of things, where it's proprietary and we don't really want to share exactly what we're doing, but so it can be kind of a challenge to get government sponsors on board with saying, oh yeah, here is a good reason to do publicly kind of tell people about this technology and share it. But yeah, my department specifically, we're really open to kind of publishing stuff and really like it when people do that. So
Yeah, honestly,
Yeah.
no, like, if you were like applying to other jobs or whatever, like how much would you be allowed to talk about your work and stuff?
you have to go, there's a process you have to go through. So if you see at the bottom of my slides, everything says like that it was cleared to go through. So yeah, there is like a public release system that you have to go through with anything you want to share outside of MITRE or outside of even the government sponsor that you're working for. And so it is kind of a lengthy process, but yeah, you are able to share a lot. You just have to get it approved that you aren't sharing too much. Yeah.
Question there.
Oh yeah. So on the federal government's climate policies, mitigation strategies, other environmental issues. Yeah, so this has been kind of a oh, sorry, now everybody can see the question. Because I can see it on my screen. So do you know, should I just read it? Yeah, okay. So Martin, oh, hey, Martin. Thanks for your time, Mitch. Does MITRE consult on the federal government's climate policies or mitigation strategies, other environmental issues? Yeah, so this has been kind of a more recent development at MITRE that climate has been what we called kind of a horizon strategy, which means a long-term goal at MITRE to kind of contribute in this area. And so in our division specifically, it hasn't really been about mitigation, but more just about adaptation. So we understand this is what's going to happen. How can we sort of pool our resources in order to adapt to this changing environment? So one example is with wildfires. So with wildfires, we know it's going to be happening a lot more often. We know that they're going to be a lot more difficult to kind of control. And so how can we use artificial intelligence to either predict the spread of wildfires in order to help firefighters adjust where they want to kind of fight it, where they want to apply those firefighting capabilities to exactly. And so yeah, so that is sort of become a priority at MITRE in order to engage these government sponsors in saying, hey, this is coming down the pipe. You're going to want technology that's going to be able to handle these different unfortunate climate outcomes that are going to becoming reality kind of in a few years. And so yeah, so that's kind of been MITRE's role as far as my experience. Yeah, thanks for the questions. All right. All right. So kind of a pie graph of what kind of a typical day for me looks like. So a lot of time is spent kind of just in meetings. So about 40% just kind of in meetings, either internally or with the sponsor itself. So internal is more about kind of communication strategy. So how do we want to talk to the sponsor about what it is we've been doing? And then the actual sponsor meetings is just more about presentation about what we've been doing. And then about 60% of my time right now is mainly on domain research or specific artificial intelligence research. So specific artificial intelligence research might be looking at kind of that state of the art, what's the best out there right now, what kind of solutions exist that we can just sort of lift and stick to this problem, or are we going to have to create a new one, things like that. And then domain research is a lot about what is the problem that their government is actually having. So what is the problem that they want us to solve? So sort of an example that for me in my own work is I was tasked with collaborating between Florida International University and US Southcom on IUU fishing, which is illegal, unreported, and unregulated fishing. And what the Southern Command wanted us to do was actually illustrate this problem that was happening sort of in South America. So where a lot of these East Asian countries are going to be sending fishing boats over and fishing illegally in the waters there, but they couldn't really publicize this because they either didn't have the time or the capability to publicize this kind of classified information. And so what they wanted us to do was sort of gather the resources that were out there and really highlight why this was a problem that was happening in South America. And so what I was tasked with doing was sort of understanding, what the problem was, what kind of areas were being fished, what kind of fish were being fished, what were kind of the consequences of illegally fishing, and then use some sort of data techniques such as like visualizations, like Sankey diagrams, choropleth maps, heat maps, things like that, to really illustrate why this was such a big deal and what would happen if there weren't stricter kind of regulations in place. And so that was just a ton of time just trying to come up to speed on that problem, and then use my background more as a statistician than an artificial intelligence researcher to kind of illustrate it. Right. And so, oh yeah. Go ahead. Mhm. Yeah. So it's a lot of more like the other side, like the consulting on the submissions, I guess. So like consulting on the submissions about what might be the best one to fund instead of that. Because it's a big no-no to apply for funding in the same place that we're consulting for those submissions already. And so I think DARPA is one where we consult on them and can't apply for those. Yeah, I believe so. I believe there's a project at DARPA called GUARD, which is about trying to use simulation-based techniques to understand how AI agents can be attacked. And so through trying to research what is possible ways to attack different AI agents, and then use that information to actually build defenses kind of against them. So I think, yeah, there is a project at DARPA, and then I think another sponsor, but I'm not sure. I'm not on that one personally, but yeah, I know there's projects through DARPA that we are being funded by. Yeah. All right. So, so the different tools I use. So in a lot of development work, mainly Python. So Python, as far as like machine learning and artificial intelligence goes, is kind of the gold source for community development, kind of helpfulness for what is out there, kind of help being able to program. And so a lot of my time is really spent kind of in Python. And then Docker is another tool that I use. So in academia, it's not really used as much, but in the industry, it's such a lifesaver, such a time saver. What it basically does is it allows you to kind of share what you've been working on with other people in a very like useful way. So a lot of times when you share kind of projects, you have to share how you actually set the project up. So you need this sort of environment, you need these sort of programs, you need this sort of operating system. And so if I wanted to share something as a Windows user with a Mac person, then you have to go through a whole bunch of hoops in order to do that. But with Docker, you can just containerize everything, pick an OS, pick exactly what you want to download, throw it all into Docker, share it, and then what Docker is able to do is actually just run it immediately off of another person's system. So don't have to worry about setting up any sort of the requirements or the environment. Just as long as they have Docker downloaded, really easy to share. So that's been a huge time saver. And then GitLab, of course, is another Git kind of solution for updating code, working on a team with code in order to do make sure all the updates aren't overriding each other, things like that. Personally, I use PyCharm, which is IDE for developing Python code. There's also kind of Jupyter Labs. There's also VS Code that people use, but for me personally, I think PyCharm is the best way to kind of debug code. And then as far as like corporate stuff, so communication, so Slack, and then all of the Office 365 tools. So you have to do a lot of kind of writing and explaining about what it is, the methods that you're proposing. And so these are the kind of things that people understand, people can work with, that you have to be able to communicate with. It's not all going to be about, here's my code output, here's a table with a bunch of numbers. You have to kind of be able to draw things, to visualize things, to make very helpful graphics. And so being well-versed in kind of these tools is also very essential. All right, so I think next I want to talk about a specific project. Do you have time, Gilad?
So have like 15 minutes.
Okay.
Question.
All right, cool. All right, so just kind of talking specifically about a project I did when I first came to MITRE. So this is a project trying to transfer what is in a static image into software. And so the items that were in these static images were kind of in systems engineering diagrams, where it tried to show like different hardware, the connections between them. And what we wanted to do was for these like old legacy systems where everything was just kind of in a binder or in a PDF, is actually transport these images into more modern software that you could edit them in place. You could draw different connections between them. You could use, you could add new sort of elements into these diagrams, whereas before they're just kind of like static images. And so the goal wasn't to be able to use sort of artificial intelligence technology to see what the text was actually saying in these images, what the connections were between these different hardware elements, and then actually transfer that information into this modern software. So yeah, this is kind of another way to say that. So a problem statement, we have a lot of system engineers kind of working on legacy systems. And what we want to be able to do is take those paper-based images and transfer them into modern software here on the bottom right, where you can actually tweak them without having to recreate the entire diagram. So these are kind of the 7 steps that we looked at specifically for creating this solution. And so the first one was actually to be able to locate where in the image the text was and recognize what that text was actually saying using optical character recognition. Then the next step was locating the shapes, which is going to be the indicators for what hardware elements they were in the actual diagram. And then the lines are going to be the connections kind of between these different shapes. So how maybe is one thing connected to the other? Usually in these diagrams, it's by drawing a line between them and then describing what that line means, kind of with text. And then after you located the actual lines, what the connections actually were between the shapes. And so it's one thing to say, okay, there's a line here and a line here, but what you have to actually do next is say, okay, what do those 2 lines connect? What 2 objects do those 2 lines actually connect within the diagram? And then unfortunately, the lines themselves aren't the whole story. There's different types of lines. And so lines with different arrowheads might mean different things. And so then you have to actually like extract that information as well, which is the step 5, defining the relationships. And then after you've collected all that information, actually associating these objects. So you know you have the text in this location, you have a shape in this location, you have to associate that text with that shape, and then you have to associate those things with other text and with other shapes, et cetera, et cetera. So those are kind of the 7 steps that we wanted to do for the system. So the first step, actually locating the text. So we used a convolutional neural network in order to actually highlight where in the image we thought the text was. And so as you can see, it's able to get quite a lot. So it's able to get all the text, a lot of the numbers, and a few false positives as far as like highlighting this person's face, for example, in the diagram. So after we locate the actual text, then what we want to do is use some OCR to actually translate what that text is saying in plain English. So taking a picture of text and outputting kind of what those characters are. And so the first step is to, in order for the optical character recognition to actually work, we want to make sure we have a good type box around the text. And so one way we can do that is by taking those initial findings by the convolutional neural network and sort of highlighting each letter individually. So we highlight each letter individually, we get each letter's bounding box, and then what we can do from there is actually combine those bounding boxes to get the entire line of data. And then just using a commercial kind of off-the-shelf solution for optical character recognition called PyTesseract, we can actually take that image of what the text is and then output what it is actually saying in kind of a string. And so after we find the text, what we want to do is we don't want it anymore in the image. And so we use those same bounding boxes to just wipe them out completely. which gets to our next step. So after we've wiped out all the text completely, then we can actually start locating the shapes that the text is contained in. And what we decided to do was use these kernel methods, which you can do to actually see where things kind of correlate the highest. And so we came up with different kernels for corners. So this is for if you have a rectangle shape in your object, we can find out where all the corners are in the object and then deduce kind of where a rectangle should be based on finding those corners. So we can find top left corners, top right corners, bottom left corners, bottom right corners, and then just kind of where, based on what we know to be true, which is that corners will share coordinates kind of within an image. So the x coordinate of the top left corner will be the same as the x coordinate of the bottom left corner. The y coordinate of the bottom left corner will be same as the y coordinate of the bottom right corner. We just can kind of do that and enumerate all the solutions and then be able to find exactly where those rectangles are. And then after that, we want to actually locate straight lines. And so straight lines, we can use kind of a line detection called Huff line detection to get sort of a disparate solution for where all the lines are. So you can see, even though this is one line, the line detection detects a lot of different lines. And so what we can do is then combine each of those each of those different lines in order to say, okay, there's probably just one line running along through here. Let's just make it one line instead of 10 different small lines. So find all the lines that are connecting the actual shapes together. And so the reason we had to do this after finding the shapes is because we don't want the lines connecting things to be misconstrued as shapes themselves. Then we can actually connect the lines to form the connections between the shapes. And so here, what this GIF is showing is that once two lines are connected together, then we create that as just one line. And then once the two endpoints are connected to a shape, then we say, okay, those two shapes are actually connected together. And so what you see when it goes from blue to green is that lines are connecting. And then once it goes from green to red, we can say, okay, those are two shapes being connected together. All right, so now what we have is kind of what shapes are connected to each other, but we don't have what kind of relationship that is. So this is kind of where the machine learning comes into place to do image recognition. So depending on what sort of connections we are expecting to see in the model, we can use trained sort of machine learning algorithm to recognize what those endpoints are. And so based on what those endpoints are, then we can say, okay, we see these two endpoints between the shapes. This must be sort of a relationship that means implies, or this relationship means does not imply, something like that. And so actually being able to deduce what those relationships are between the shapes. Once we have that, we have kind of all the information we need in order to build this diagram. So we have what the text says, what shapes the text are located in, what shapes are connected together, and what the relationship is kind of between those shapes. And so what we can do is actually create sort of a graph diagram that's connecting all these different elements within the image, but now have it saved on our computer instead of just in this static image format. And so once we create this graph, then we can translate this graph information into this modern software that can be ingested, or that can ingest it and actually be able to create or be able to edit this diagram on the fly rather than having it just be contained in an image. So yeah, so kind of the three-step process is you have the static image, you create a graph, internal graph from it, and then you can output it into some modern software. Here we used a tool called Cameo. And so just some examples, I'd suggest focusing on one at a time. So of kind of the different steps. And so what you can see is that we're kind of recognizing the text, deleting it, recognizing the shapes, deleting those lines, recognizing the lines, deducing the connections between the shapes, and then deducing the relationships between the shapes, and then creating that graph from all that information. So yeah. And then here's the paper. that we actually were able to publish from this work. And so the tool we called ArchEx for architecture extraction. And for the sponsor, what they were able to do is sort of use it as a prototype, as a way to say, okay, let's try it on some of our images that we have and see if it's actually useful. And that's kind of where it is right now. All right, so I think I wanted to kind of just close with some tips for interviewing kind of in industry. And so I've been on quite a few interviews. And so the things that I'm kind of looking for that stick out to me is, so if you're going to list a project on your resume, you have to make sure that you can be able to talk about it. So you have to make sure that you're able to intelligently explain kind of the decisions you made, be able to justify why you made those decisions, and have to kind of just be able to really avoid probably projects that you don't know much about, or that you were just kind of doing what you were told. So a good answer is, oh, because my professor said so. So that's not a very good answer that we want to hear. We want to be able to hear kind of your own thought processes about why you did something. Another big thing is being able to highlight the impact of your work. So saying that you did this project is really cool. It shows kind of your knowledge, but being able to highlight the impact about saying it's been used by this many people, it has this many stars on GitHub. One person I've seen on their resume says it's been used by a brigadier general or something. So just very cool things that you can actually say, not just what you did, but how it affected sort of other people and how it's been used sort of in the community. And this one's really hard. So don't think of it as something that's like incredibly necessary when interviewing. But if you're able to say something about it, I highly recommend it. And then also just kind of be yourself and be prepared. So we love kind of chatting with people, just finding about who they are as a person to see if they would sync well with everybody else in the department. And so just kind of be yourself, but also come prepared to answer sort of technical questions. So I interviewed a guy one time that wasn't really able to answer a lot of technical questions. And at the end he said, oh, I'm just so nervous. And it's unfortunate because we can't tell the difference between him being nervous and him not knowing the answers to the questions. And so definitely come prepared to talk about these different technical things about your projects, just to show your best self. And yeah, I think that's all I had. So thank you guys so much for listening, and I'm happy to take any questions.
Thank you very much. It was very interesting. People at home, you can type your questions in question and answer box.
So you said with the example you had, like ones such as like box detection.
Oh yeah.
Like is it easily like adjustable to like if they have like ovals or like clouds or like other shapes?
Yeah, so that method specifically about detecting the rectangles isn't, but we did have ways you could detect like circles and ovals, and I think we got to triangles. So those kind of more those different shapes. So once we got into, there was like some cylinders or something, we had ways where you could like manually input a shape. So here's an image of the shape, and then we can try to draw kind of what that shape looks like and be able to find it sort of in the image. But that it wasn't as reliable as just having sort of like a concrete method in order to find like circles or something like that. So there was a bit of a manual process in order to find kind of different shapes than the kind of well-known ones or used often ones, but it was possible, I guess. Oh yeah, Martin. Thanks. So Martin asked, so Microsoft is integrating OpenAI tools in Office. Have you consulted on the use of this within the federal government? Thanks. I have not specifically, but my division is heavily involved with it. So there's been a lot of talks, a lot of communication about how we can integrate these tools such as GPT-4, ChatGPT into the government systems. So a lot of questions that we're getting from government sponsors is, how expensive is it? Do we have the hardware to do it? Can we use our own data with it? What are the things that we should avoid inputting into kind of the conversation? things like that, like how close is it to being open sourced? So we're getting a lot of questions from the government sponsors about this. And since it's so new, what we're basically saying is that we're just gonna have to kind of wait and see what exactly it is, how much is it going to cost to be able to kind of use. And so while I specifically haven't done anything with this, I know my department is heavily involved with trying to help the government acquire that technology. Yeah.
Just related to that, but for your
Mhm.
describe how did you validate that model except by doing a lot of manual
Mhm.
software checkings? That's not a large part of it.
Yeah, so a large part of kind of the validation was kind of ease of use, how accurate it was, and so needing that ground truth. So for ease of use, it was more about you having people that used kind of these software tools already and seeing how easy it was to use our tool compared to manually creating a brand new diagram from scratch within this modern software. As far as the ground truth, we didn't have any because there wasn't anything about here are the coordinates where there's a line, here's the coordinates where there's text. There wasn't anything like that. So a lot of it was kind of just based on the eye test and using these experts to say whether it did a good job or not. I think one effort we had while I was still on the project is creating synthetic diagrams and just being able to use those for ground truth. But yeah, we didn't actually integrate it or anything like that. So yeah, good question. Thanks. Mhm. Oh, it was the IEEE AIPR, which is the I think automatic image pattern recognition, I think. Oh, the support of the product. So that was internally funded. So that was something where we went to MITRE internal people and said, this is something that people will be interested in, but the technology doesn't exist right now. We want to be ready to actually have people use it when they need it, kind of thing. And so. Mhm. Mhm. Yeah, exactly. Yeah.
Curious about kind of following on the question about using like OpenAI and Microsoft kind of tools in the government. Like you sound like MITRE works a lot between like government and private industry is like Microsoft is like using like OpenAI stuff and Bing. Do you see like a gap between what like how willing private industry is to like trust AI or like how good their models are versus like government models, or think they're like pretty close in your experience?
So I think there's like a definite gap. So the government does not move as fast as private industry. And so there'll always be kind of a bit more red tape you have to go through with the government in order to get things approved, in order to use their data, certain data, to actually train these models. And so with the private industry, they're able to move a lot faster, commit a lot more resources kind of on the fly to something that they think is going to have a huge potential in the short term. And so kind of where MITRE is trying to do is trying to close that gap by either saying, okay, yeah, we can kind of duplicate what they've been doing like this way, or we're going to evaluate kind of the best solution for what is out there and kind of bring it to you to decide whether it's worth it to build it in-house or acquire it from kind of a private industry. And so yeah, and a lot of times it is kind of prototyping it for the US government to say like, okay, this is kind of our experience with prototyping it. If you want to try it in-house as well, or try it on your own stuff to see if it's worth buying it from private industry. Yeah,
this is maybe a very general question that we can maybe transfer, but from your point of view, what are the tools or techniques that the government seems very interested in these days?
Government seems more interested.
You see there are things that they're trending right now, like ChatGPT and
Yeah.
all this, but for the government.
Yeah, no, I think it's really similar to kind of what you see that people are interested in general. I think the government is is very knowledgeable about what's going on, but also knows that it takes a long time to adapt kind of things. And so it might be that they're a bit behind on adaptation because they have to go through such a rigorous process to acquire kind of these different tools and stuff. Yeah, I personally don't really see a difference between what the government tools that the government's interested in and what the kind of private industry is also interested in, because a lot of the differences is just kind of how it's being used. And so that's kind of where the distinction between what the government does and what the private industry does. So kind of what private industry does is they want to kind of get people to click on things, get people to see things in order to spend some more time at their site, things like that, where maybe the government's more interested in using that information extraction to summarize, for instance, instead of like continue that interaction, I guess. So I think a lot of the tools are the same, but just why the government wants it maybe a little bit different.
So that focus system over time.
Mm. Mhm. I guess I think it's becoming less and less, especially in artificial intelligence. It used to be that it was a pretty niche area of like industry and research where people didn't really understand what it could be used for, and it wasn't really beating humans at things. And so there wasn't really a reason to really invest in it. And so the government kind of was able to kind of utilize it in different ways that were maybe not apparent to what everybody else could use it for. I think probably one of our moonshots at MITRE is sort of an oncology database. And so what that is trying to connect all the data for different cancer patients within the United States throughout all like the hospitals and stuff, and trying to understand when we can aggregate this information and connect it together, what can we actually do with that information? And so I think for MITRE's point of view, those are kind of the things that we want to spend like 5-10 years on to actually build those things that people aren't going to want to invest in right now, that aren't going to see the immediate impact of those. Another kind of long-term investment we have is in quantum computing. So that's probably another area where it's not really apparent right now where private industry would utilize kind of quantum computing, where it's the technology that's pretty far in the future and not really like integrated into a lot of systems right now, but there's a lot of kind of research being done in that area. And so yeah, and so yeah, kind of these companies that have a lot of money are now kind of being able to move in that space as well. And so yeah, I think it's definitely becoming less and less as like these companies that are as far as my like kind of in artificial intelligence, they're able to do things kind of a lot quicker and a lot faster than the US government. Okay. Okay. Yeah. Cool.
Thank you very much.
Yeah. Thank you.
We're going to have a follow-up discussion